Thanks for tuning in to another physics lesson with Mr. M. And today we're going to be covering the topic of the conservation of momentum. If you recall, momentum is just an object's force when it's moving. If there is no movement, we have no momentum. And the equation that we get for momentum is that object's mass times its velocity. And so we want to relate that today and learn about what is known as the conservation of momentum. And so as you see here, we have a picture. Looks like we got a truck and a car. Usually when we're talking about the conservation of momentum, we are dealing with two objects that are colliding with each other. Okay? And so this word conservation, or to conserve, what that means is we're preventing the loss of, or we're saving up. Okay, we want to relate this word to our momentum, and so that gives us the conservation of momentum, which means that the total momentum between objects before a collision is equal to the total momentum after the collision. So there is no loss of momentum, nor have we gained any momentum. So in other words, the total momentum of the system does not change. That is what is referred to as the conservation of momentum. However, some conditions need to be met for the conservation of momentum. There are two conditions. The first condition is that momentum is only conserved in a closed system. And in a closed system, we have not gained mass or we have not lost mass. So in other words, if we're talking about two objects that are colliding, we have not done any alterations to those two objects themselves. The other condition is that there has to be no external forces acting on the system. And when we have no external forces acting within a system, we call that an isolated system. Now in the real world, this is quite hard to avoid. However, some of the external forces are so insignificant that they really don't kind of mess with the conservation of momentum. However, these are the two conditions that are met for the momentum to be conserved. Now you might be asking yourself, well, how does this happen? Why is it that momentum isn't gained or lost in a collision? Well, you kind of have to think back to Newton's third law. Okay, as objects interact with each other, the force that they exert is equal and opposite. Okay, for every action, there's an equal and opposite reaction. So because the force exerted between those objects is equal, and the fact that when they come in contact with each other, the time that they are in contact with each other is also equal. Okay, this is also known as the impulse of the collision. Because all of those conditions are equal, then our total momentum before and after the interaction is also equal. So the main reason why momentum is conserved is really due to Newton's third law, okay, which once again states that as those objects interact, the force that they exert on each other is equal and opposite. Now, usually when you're dealing with momentum, the conservation of momentum, there are really two types of collisions. The first of which is known as an elastic collision. This is a collision in which the kinetic energy is also conserved. Kinetic energy is just the movement. And so one of the ways that this is also described is that when the objects come in contact with each other, those objects will bounce off of each other. So some examples is like playing billiard balls, or even gas molecules will bounce off each other. On the other side of this, we have what's called an inelastic collision. This is a collision in which two objects will collide and remain together, and they go off with a common final velocity. So another way to put this is that the objects will stick together. So some examples of this would be like a rear end car collision, or if we throw two lumps of clay at each other, they will theoretically stick to one another. The main idea here with these inelastic collisions is that before the collision we have two separate objects with two separate momentums, but after the collision those two objects will act as one single object, and they will have one single momentum or one single velocity after the collision. So beforehand, two separate objects. After the collision, they act as one object. Okay? One of the key points to keep in mind here is that in both of these types of collisions, the total momentum is conserved. Okay, that does not go away. Okay? So in review, momentum is conserved in a closed and isolated system, which basically states that the momentum before the collision is the same as the momentum after the collision. This is due primarily because of Newton's third law. This is why the momentum is conserved, and momentum is conserved in both elastic and inelastic collisions. So hopefully this video was helpful for you in helping you with some physics problems or even the concept of the conservation of momentum. Thanks for tuning in.